Welcome back to Educator.com, Introduction to C++. Today we're going to talk about a number of little things that we're also going to talk about again later in the class, but we want to get started in terms of get a compiler, get going. So we want to get a compiler. You need to get a compiler of your very own, put it on your machine. I hope you have a machine. If you don't have a machine, what are you watching this on? Okay, you've got a machine. You have to get a compiler, get an integrated development editor, or called an IDE. I highly recommend that over some other editor. Or you can get a text editor. Sometimes it's good to have a text editor. You can edit things outside of the IDE. And we'll write a C++ program. We'll talk about program structure, brief introduction to that. We'll talk about compiling, linking, and running your code. Some build tools, basically make and whatever else is out there. Then we'll have your second C++ program, your third C++ program, and we'll get started right now. Okay, we need to get a C++ compiler. The one I recommend is the GNU C compiler, which is GCC. Never mind what GNU stands for. But it's every man's workhorse. It's been around since the 70s or 80s. It's free. The GNU people basically launched open source as you know it today. There's a lot of things that are available in open source. It doesn't necessarily mean it's free, but in many cases it's easily available, which I haven't spent a whole lot of money. We can get GNU for Windows. Most of you are probably running a Windows machine. So you can get something from the Cygwin project, and they emulate a POSIX system, which is a type of Unix system. This is where you can get it from. Or you can get the MinGW, which is the minimalist GNU for Windows, and you can get it from their website. Now, I'll be using this one for our class, the MinGW. And you can also get Microsoft Visual Studio. There's Visual Studio Express, which is free, or there's a paid version which adds more features and more support, different things like that. Just keep in mind you may have to do special configurations to write standalone code as opposed to code that hooks into .NET and other Microsoft goodies. And of course, you can get that from Microsoft's website. I have a quick thing here for setting up MinGW. It's a little tricky. You download it, you install it, it puts everything into a particular location, and you will need to worry about your execution path. And we're not going to talk about this. We have a download file that you can download. It has all this instructions that you can look at. And you get MinGW on your system and compiling. This is how you test it, how you run it, compile something for a specific type. And we'll talk about a little bit more of this later on today. Now, if you're not on Windows, you have Red Hat, Fedora. There's a number of Linux systems out there. There's also Unix systems out there. I'm not going to worry about Unix systems. Your Red Hat system or Fedora is one style of Linux, and this is how you get it. If it's not already on the system, very often it comes with it already. So you log in as the root user, which I hope you know how to do for your machine, or if it's not your machine, get whoever owns it or administrates it to take care of this for you. And this is the command line you run from a command line window. Don't try to go into GNOME or KDE, all those other Windows emulators that works on it. You have to open a command line window and type this command as the root user. Ubuntu, based on Debian, is another very popular Linux distribution. There are many distributions of Linux that are based on one or the other of these, and this is the same thing. Get a command line window, start typing the commands. These are the commands that you would type to get that installed on your machine. If you're on a Macintosh, you have to go to the Macintosh website, register as a developer, which is free. It's not a big deal. They'll just send you an email every once in a while about all the wonderful new things they're selling. And you want to download Xcode. Make sure you get the right version for whatever version operating system you're using. Now we have an integrated development environment, the IDE. Eclipse is my favorite. There's a bunch of other ones out there. You get the Eclipse CDT, which is the C++ development tooling, and it requires the installation of a compiler. And again, I'll be using MinGW for the class. So go to this website, www.eclipse.org/CDT, to get the CDT version of Eclipse. Eclipse is very easy to install. You download it, you uncompress the file, you locate the Eclipse executable, and you run it. You're done. That's all there is to it. If you already have Eclipse, because you've been using Java or something else out there, you can go to the Help menu, install new software, select all available sites. Now, if you've never done this before, it may take a little while to install, because what it will do, it will go to the Eclipse website, and it will download all available sites. So give it a couple minutes. Once it's been populated, select programming languages, and then select C++ development tools, and that will click that, OK, everything else, and you'll get the CDT downloaded and added to your existing Eclipse setup. If you have an older version, here's a website you can go to get it just for the older version, but you probably should be better off just get a newer version. It doesn't take up that much space on your disk, and you usually want to have the latest version of things anyway. Now, if you don't have an IDE, if you can't use an IDE for whatever reason, there's various editors you can get. On Windows, there's Notepad, and if you're really desperate, because Notepad it's got problems. You don't want to use Notepad. There's Notepad++, which is available for free. There's their website, notepad/plus or --plus-plus.org. There's something called NoteTab. There's their website. I prefer Programmer's Notepad for no particular reason. It's just one that I happen to use. It's pnotepad.org. A lot of people swear by Emacs. It has almost a cult following, especially in the Unix Linux world. You can get a version of Emacs to run on your PC or on your Macintosh if you want to give it a try. Find out what all the hullabaloo is about it and use that. Or if you're already familiar with Emacs from working with Linux or Unix or something like that, just get Emacs and use it. I don't care. Or you can get Eclipse and just use that. Vim is a cute little program that's available on all Unix, all Linux systems. It'll either be Vim or VI. Vim basically is the open source version of VI. And you can also get that when you download MinGW onto your PC if you want to give it a try. If you're on the PC, I wouldn't recommend it. But if you're on Linux, sometimes it's the only way to go. So it's available on Linux. Just learn how to use it. So like I said, on Linux, we've got Emacs is very typical. Vim, guaranteed to be on the system. You can get a Linux version of Eclipse and download it to your Linux machine. Macintosh, there's a list of all kinds of wonderful software that's available for Macintosh that has Apple's blessings. You can download it to your machine if you have a Macintosh. Or there is an Eclipse version for the Macintosh. You can get that. All right, let's take a break here. We've talked about a lot of stuff. So make sure you have everything you need. Go to these various websites, download your compiler, install them, download your IDE, install it. So we're just going to take a break right now, and you just freeze the video, hit the pause button, and come back later. I'll still be here. And welcome back. I told you I'd be here. Okay, we're going to write our first program, Hello World. Everybody, whenever time you're learning a brand new language, your first program is Hello World. You want to write something, Hello World, here I am. So that's everybody's first program. Here is an example. We have some comments, and the name of the program is helloworld.cpp. The author is your name here, so put your name there. This is version 1. Make sure your revisions are kept up to date. You can copyright source code. You don't have to send it into the copyright office, but you do have to say, yes, this source code is copyrighted. It's not a great deal of protection. It is some protection. And here's a description of what the program is. This is known as your preface block. Many companies require every source code has a preface block to explain what the purpose of the program is. It's a good idea. You don't have to do it for this class, but I would suggest you do it. Get in the habit of explaining what your intentions are. Now here, our first line here is actually an include directive that's going to get the IOStream library interface. This is what has your outputs, your inputs, your file descriptions, various things like that. And what's a program without input and output? It's not going to just sit there and twiddle its thumbs. It's going to do some calculations and at least output what those calculations are. We have using namespace. Everything in the C++ library, it generally is in the STD, the standard namespace. And we're going to say we'll be using this so we don't have to specify on each line. Here we have the beginning of our function, our main function. Every C++ program needs to have exactly one main function, which when you run the application, it will look to find, give me the main application, I'll start running. You can have other functions that are called from inside there, but you have to have the main. Here's another comment. It says what we're doing. We're going to print hello world. And here's our cout, which is part of our IOStream. Here is a output insertion operator, which will take some text or some values and insert it to the output stream. And here's the text that we're going to be outputting. It says, hello world. And we have another insertion operator because we're going to be inserting more after that. And what we're inserting is this keyword which says end of line. So we'll be printing this out followed by an end of line. And then we have return 0. This will be, since this is an integer function, we are returning 0. And since it's the main function, this 0 will be returned to the operating system. This is very often used for error reporting. So if something goes wrong in your program, you're testing things, you're validating things, you detect some problem, and you want to kick that back up to the operating system, you will return something other than 0. You return 7. And then you have your paper, the program is, oh, it returned 7. Oh, 7 means that this went wrong, so then you can go do something about it. And here we have the code is inside your curly braces. There's your open curly brace and your closed curly brace. So let's take a look at that in Eclipse. There it is. I wish I could make this font larger, but it's in the configuration. We don't really have time for that. So we just saw it on there. And we have this. This is the other type of comment, which is a slash asterisk followed by an asterisk slash. And it prints hello world. Let's make some changes to the code. I'm going to make changes to the comment. This is my first program to say hello to the world. Now we're going to appear a little save button, and the hammer is to build every C++ program has to be compiled and linked before you can run it, because it gets to be compiled from C++ code down into machine code. So here's our status. Here's what's going on behind the scenes, and build finished. It says right down there, build finished. Okay, good. And there's no errors. Lovely. Let's put an error just to see what happens. Let's put out here. this is an error, because that's not legal C++ code. Uh-oh. It's already done a little bit of compilation in the background. And if you put your cursor over it, it says right there, hey, I don't know what any of this stuff means. If we compile it, or build it, it will come back and say, hey, I can't do anything with this. Look at this. I got all these, it underlines all these nice little errors. And there's also a little red thing over here that which, if you've got dozens and dozens, hundreds and hundreds, thousands of lines of code, you can find your errors by coming over here to the right, and tells you what's wrong and allows you to click to go right to the error. So let's get rid of that because this is wrong. Of course, the quickest, I could just comment it out, but I'm not going to do that. I'm just going to erase it. And look, a little error thing disappeared. We'll save it. We'll build it. And it'll be very happy in a second. And here's our little green triangle is to run it. And there it goes. It prints hello world. How about that? Let's put something else in here. Let's say I want to state output. Not single quotes. We want double quotes for a string. The number is 7. It already put the closing double quotes. And I'm going to put a 7 here. And then I'm going to put another string with a period. And the end of the line. Well, let's not do that just yet. Here, do something real quick. We'll do that. We have a 7. And then we'll do this on the next line, end the line. So we can do this any kind of way that makes the most sense to readability. We'll save that. Build it. And our build is successful, and we'll run it. And it says, hello world, the number is 7. And there's the 7 right there, which we asked it to print. So let's go on to our next slide then. So we have some basic program structure. Now we saw a line of commentary. Basically what you have is 2 slashes in a row. You can anywhere in the program, and from that point to the end of the line, from here until it gets to the end of the line, is the comment. Here's a great example. We have an integer defined, a variable called WPH, and here's our comment that says, well, what is WPH? WPH is widgets per hour. So there is the comment that describes that variable for the reader. It's very important to communicate with the reader to let them know what it is you're trying to do. Now here's the other style. This is inherited from C, which is still used in C++. Your slash asterisk begins a comment block. Everything inside there is a comment until you get to a closing asterisk slash. This allows you to do multiple lines of comments. And we have beautiful little decorations. So use comments to describe what the code is attempting to do. The decoration here is optional, but it's nice to draw the reader's eye to this particular comment. It says, here, this is important. Read this. You need to know what this is about. I've even seen them have equal signs, hyphens, all sorts of different things. So the first line of actual code after the comments in our hello world was to include the IOStream library. Whenever you have a library header file that's required to define all the various things you're going to use and how they're being used, you need to include that file into the file that's using those things. So we also have the C standard library. So there's just a couple of examples of things that can be included using the include directive, #include. And here we're defining our default namespace, which is std. If you don't specify the namespace, it will assume it's in the standard namespace. Here's some examples. With this, using namespace std, we can say cout, insert text, insert the end line. If you don't happen to have that namespace defined, or some other namespace is defined because you're incorporating some other programs from some other company, then you have to specify it with the namespace operator. Here's std, cout is part of the standard library, is in the standard namespace. The same thing with end line. So here's our operator, here's the standard namespace. And don't worry about it right now, it's just something that you have to remember for later. Occasionally you need to do this, but we're not going to be needing to use it in this particular class. Now, your global area basically is everything that's before the main function. That's where you can define your global variables, your constants, structures, classes, etc. Where you bring in your include files, which will be defining global variables, constants, structures, classes, etc. And then you have finally your main function definition. You have int main. This is a function, just like any other function, and it follows the function syntax, except it must return an integer. You can have arguments in here, but we're not going to be dealing with those in this particular class. Then we begin a block of code with our open curly brace. Here's some statements. We just happen to have 2 statements in hello world. We've got our cout, say hello world, and end line, and return to 0. And then we end the block of code. So there's your basic structure, your int main, begin the block of code, statements, end the block of code. Now, C++ is a compiled language. There are other languages that are interpreted. The computer reads your code as you type it and then converts it to machine language and executes it right there on the spot. C++ usually is compiled. It will take your source code, which is in human readable text, and it will translate it to a machine code and put that into an executable file. And then you take that executable file and put it on any machine that's compatible with it and run it straight off. In this particular example here, note the extensions. We use, this is the file name extension, .cpp. This can be on some systems. You can have .C. I don't recommend that because Microsoft Windows is not case sensitive. You can have .C++. There's a couple others, but I always like to use .cpp because there's no plus symbols and it's just CPP. So this particular command line, you can open up a command line window and you can type C++ file CPP, and this file contains your CPP, your C++ code. If you've got a GNU compiler, you may need to do G++. Sometimes you can do CC, and it just knows by virtue of the C++ extension that it's a C++ program. Sometimes you do GCC, same thing, but basically C++ is the command. Here's an example creating an O file. We add the -C option, which says compile this into an object code. So it creates an object file.o. Now this is used so that you have various C++ files. Each one's a different compilation unit, and you want to link them all together. So .file.o is an intermediary language between C++ and the actual machine language. Here's an example where we actually build an executable. This first one, if it has a main function and that's all it needs, this will create an executable called a.out. Or if you're on Windows, it'll create a.exe. This one creates an executable called file exec because you use the -O option to say, this is what I want the name of my executable to be. And here's an example of linking some different compilation units together. So we've had up earlier here we had a C++ -C, a file 1, and a file 2, and you can have file 3, file 4, all sorts of different names, and you compile them into object files. You might buy a .o file from a different company that we've written all this wonderful C++ code, we've compiled it into a .o. If you give us a bunch of money, we'll share the .o file with you. You can link that into your applications. You can do that too. And here we have, and we're linking together the object files and building an executable file. And then you run it. There's a couple of possibilities. You can either just type the name. If you're on Windows, if you're on the command line, just type executable. It'll be .exe here, but you don't need to type that when you want to run the program. Or sometimes you have path situations. It doesn't know. If you're on Linux in particular, you may not have the path leading to your current directory. Running it this way says to run the executable in my current directory. You won't have to worry about any of that if you're in your IDE. And there's some other build tools. There's a make program that allows you to create a make file. We're not going to talk about that too much in this class, but it's just something to keep in mind. When you build a make file, you tell the make file, this particular executable requires these object files. And these object files require these C++ files. And to get a C++ file into an object file, you run this command line. And you put all those into the make file. And when you make a change in a particular C++ file, it will go, look, oh, this is the one that was changed. We've already got all these other files. We don't need to recompile them. We'll just recompile the one that was changed. So we have a file named myapp.cpp. You say make myapp. If you don't have a make file, it will know that the CPP needs to be compiled usually. Depends on how it's set up. It's particularly in Linux. It will already have default setups. So it'll know to make a myapp program. If you're on Windows, it doesn't know. You do need a make file. But if you're in your IDE, you're in an integrated development environment, Eclipse, there's a few others out there. There's a build all menu that says build everything, or just build the things that need to be built. Another development tool, a build tool, is called Ant, which we're not going to be using at this particular picnic. Just something that if you see Ant as a build tool, you know what it is. But make may be used in your Eclipse. It will use make in the background, so which is why you need to run min-gw. It has make on it. Now we have a quick note on declaring variables. We'll talk more about this later in the class. But C++, your variables must be declared before they're used. Your basic declaration syntax is the type of the variable and the identifier that identifies the variable. Such as, here's a couple of examples. Int, current passengers. Int means integer. And allowed passengers, like if you have a 747 that you're building, you're selling tickets for. We've currently sold tickets for 205. Integer is something that counts. But we allow 307 passengers on this particular aircraft. So you can have your code in there that's testing, are the current number of passengers greater than the allowed number of passengers? And if it becomes greater, then you have to go down this branch. If it's okay, you go down this branch. And all these things we will be worrying about later. We also have floating point numbers, which is used float. Now the difference between a float and an int is a counting number. It's an integer. A float is a fraction. It's a real number. It's a floating point number. So it's not exactly a real number in the mathematical sense, in that because you're limited to the storage, how many bytes can store the number. And so when you have something like 1/3, when you convert that to a floating point number, it'll be 0.33333. But it can't go further than that. So it's not really a real number in the mathematical sense, but the decimal point can float which is why it's called a float for floating point. That's the way it's implemented in the hardware. So here's a few examples. Passenger load in pounds documented. The allowed load in pounds is also documented. And distance in feet. So you can have a distance of 12.78. If you don't have feet and inches, maybe it would have been better if we made this meters, because that way everything can be decimal. Because when things are in feet, you expect it to be 12 feet and 11 inches. You would have to have another variable for distance in inches. And then your comment there would say it's in inches. But if we say it's in meters, we can use decimal points much more easily. Now let's look at our second program. We're going to get some user input. We're going to stop we're going to print something out for the user. We're going to print it on the console using the cout output stream. And then after we do that, we'll stop and we'll wait for the user to type something at the console and store it in an internal variable. So here's our preface block. They're very basic. IO stream, namespace, the function. Here's a comment that says, notice that end L is missing. Because we don't want to end the line. We want to stop there at the end of the line and right there where the user can start typing. Here we're defining age as an integer. And we'll request input for this variable. And it skips over any white space and stops as soon as it gets white space. So here is the extraction operator. Cin is the console input stream. And we're going to put that into our age variable. Then we're going to calculate dog years as an integer is equal to whatever the user types in as input multiplied by 7. This is the multiplication operator. And then we'll print out, we'll print out the value of this variable in dog years. So let's take a look at that here. We'll actually have to get a new workspace. It'll take a minute or two. Whenever we change workspaces, Eclipse has to reload a new workspace. And here it is. Let's bring that up in here. And here's our program. How old are you? That's not a good preface block. How old are you in dog years? So save that change. Let's build it. And when it gets finished building, we can run it. And that puts it down here in our console. You notice it did not go to the next line. It stopped here because there's no end L. So I will put that I am 6 years old. That makes you 42 in dog years. So we took the 6, put into age, multiplied that by 7. 7 times 6 is 42. And then assigned the 42 to the dog years variable. And then we printed it out. Now, one thing to note on this operator, it does skip over white space. So if we run it again, we put a bunch of spaces here. It skips over all of them. And then put 9. Put some more spaces. Ignores those. Hit enter. It's 9 times 7 is 63. I hope you guys are checking this math. Run it more time. How old are you? 39. Sure. 273 in dog years. Now let's get back to this. So I want to do a quick note on character arrays. We'll talk about more about character arrays later on in the class. But since we're using them already, we might as well do a quick discussion of them. A string of characters is stored in an array. It has the type of char, which is short for character. So you have char, a variable name. The square bracket makes it an array. And then we have the length of the array. So the char type is exactly 1 byte long. The length of bytes is reserved in memory. So if we put 27 in here, it'll reserve 27 bytes. Here's an example where we're giving an initial value. We have char var bracket, the length, hopefully at least as long as what you have here, plus 1 or longer. And equal is assigning it. And then we have each one of these characters takes up 1 byte. Now, a very advanced topic, which we're not going to talk about in this class, is international character sets, which will have 2 bytes or 3 bytes or 4 bytes per character. But we're not going to talk about that. For this class, all you have to worry about is there's 1 byte per character. So 1 character is stored per byte. There's a 0 byte, which is stored last, which is called a null terminator, because the C++ compiler will put in code that knows that when he gets to that 0, that's the end of the string. Now, anything that's past the end, this initialization might be undefined. You should not depend on it having a value. It might be initialized to 0, but like I said, don't depend on that. You also have array references. This asterisk is not a multiply in this case. This is a pointer reference. So the character pointing to this var is a pointer to a character. And the first character it points to is the I in this string. So these are 2 ways of indicating a character string. So this will just allocate enough bytes for each character plus the 0 at the end. Now let's take a quick look at our third program. What's your name? Now the issue with Cin and the extraction operator. The extraction operator will throw out white space. Like we saw in the previous one, it just throws them all out until you start putting actual numbers. Now that gets to be a problem when you have data that is supposed to include spaces. Like, for example, what's your name? Well, my name is John Smith. Well, there's a big old space in there. If you just use the CN with the extraction operator, it'll go up until it says John, and then it will stop. So to get around that, we will use the getLine method of the CN input stream object. And this, we're getting into some relatively advanced topics, and we're just glancing at it because you need to know this type of stuff for this type of thing. Where CN is an object, as in object-oriented programming, the dot is the operator that says, okay, from here on in, we have a method, and the method is getLine, which says, I need a character string buffer, I need a character array that's been, you've allocated enough memory for the type of input you expect, and then the maximum number of characters to read. So this will keep reading, either until it gets to the maximum, or until the user hits a new line, or reads a new line from a file, whatever the input is. So let's take a quick look at that here. We have to go and get that workspace. Oh, we have the wrong workspace here. There it is. Yeah, go have a cup of coffee while this loads. All right, here we are. Now we have the program. Now here I changed it to 40. Let's change it to 50. So we'll request input. We'll request data until we get 50 characters in our comment. Let's save that. Let's build that program. Let's give ourselves some room here and run that. Now I can put actual spaces in there. Remember, before I did space, and then 7, and then space. It's going to keep all those spaces now. It says, hello, space, 7. Pleased to meet you. It's a strange name. 7 of 9. Yeah, you are. Let's put that in there. What's your name? We'll click into the console. And one thing, you notice a little red triangle. We can terminate this program by clicking that, the red square. So now this program has been terminated. Nothing else is going to happen. Let's run again. It's still there. Click here. What's your name? 7 of 9. And hit enter. Hello, 7 of 9. Pleased to meet you. And all the spaces are preserved. So we can put something else. Let's add another program. Let's add some more to the end of this. Let's say cout. Enter a word. And now we'll use CN with the extraction operator. And we'll go into name like we were doing before. And cout. You said name. And put end of line. Save that. Compile it just to demonstrate the difference here. And it's successful compile. What's your name? Alvin Sylvain. Hello, Alvin Sylvain. Pleased to meet you. Enter a word. Bird is the word. Enter. You said bird. See, you notice, see, the CN stops. It throws white space around. Occasionally, when you need white space, you need to use getLine to get the data in. Okay, let's minimize that. Go on to our next slide. Okay, do your homework. We have homework you can download, give you a few programs you can work on, you can start building and start actually playing around with things. We don't use multiple guest tests in here. All it does is prove that you memorized the book. It doesn't prove that you've actually learned how to do anything. The way you learn how to do things is by doing things. Repetition is the key. You do things over again. Try things other than the homework. I have homework that's done, blah, blah, blah. Hey, here's an idea. What if we do something else? Try it. Do something else. Don't be afraid to make mistakes. Everybody makes mistakes, especially when they're starting to learn something new. So if it looks interesting, try it. Just try it. You might learn something. If it fails, you learn that this doesn't work. If it works, hey, you learn something good. If you find something interesting, bring it to class. Put it in the comment section. Hey, guys, guess what happens when you try this? Everybody will learn something. And if the computer explodes, we'll bill you for a new computer. Don't worry about it. The computer isn't going to explode. So just play with things. Try things out. Oops, the computer exploded. We'll bill you. Well, that's it for this class for educator.com. I'll see you next time. We'll get into the next lesson.